Okay, so I am going to give you 1 minute and 1 minute only to look at these two and decide what they are. You can talk to your neighbor, but you have 1 minute. Okay, CJ, that first one is asking you to do what? Find the derivative of? Which is? Okay, so what is the derivative of cosine of x? Good. Don't forget that the derivative of cosine is negative sine of x. We had a couple people forget about the negative. Okay, this second one, Will, what is it asking us to find? Okay, 2 has something to do with 2 cubed. Okay, so our function is x cubed, and we're evaluating at 2. So what is the derivative of x cubed? So 3x squared is our derivative. Since there's that 2 there, we need to plug in 2. So we have 12 without actually having to do any algebra. Okay? Problems like these are going to pop up on the AP test for sure, which means they're going to pop up on your quizzes and tests. Okay? So we need to be able to recognize that. Will, did you have a question?
No.
Both you're good? Okay. All right, so today, don't write this down, but what if I asked you to take this derivative? On the quiz yesterday, what would you have had to do? Okay, CJ would cry.
Multiply it.
And he would cry because we would need to multiply it out. We would have to multiply 3 terms to 3 terms, combine like terms, and then take the derivative. Does that sound efficient? No. Okay, so I'm going to teach you today something called the product rule. Please write it down. So the product rule can be used to find a derivative anytime you have a product of 2 functions. Okay? Now I would not use it for something like 5 times x squared, because 5 is just a constant. We can use that rule. But that equation that I had on the first slide, if we had a product of 2, like polynomials, instead of multiplying them out, we could use this rule. Okay? So if you have 2 functions multiplied together, when we take their derivative, we're going to take the derivative of the first function times the second, plus the first function times the derivative of the second. Okay, so they kind of get paired up with derivative and original between the 2. Okay. All right. Don't write this down. Yes.
Can you use this with only 2 terms, or can you do like any amount of terms?
Okay, so
Like, would you just have to individually multiply each derivative to the rest of the function? do if there's like 3 or 4 of them?
If there were 3 or 4 of them, you would have to, it would get complicated, and I would have to sort it out in my head before I told you, but there would be a lot of derivatives multiplying 2 other pieces. I mean, it would be like a lot more terms. Yes. Yes. We're going to stick to 2. Okay. Okay. So, you know what? I have a proof for this, but with Pepperelli's schedule today, I'll come back to it if we have time. Okay, or I'll come back to it a different day. Is that okay with everyone?
Yes.
Okay, some of you guys are like, thank you. All right. Write down this example. I think this is the one that I did have on the first slide. Okay, so when we're getting to the point where we have multiple rules, when you look at a function, you need to decide what does it look like. Does it look like something I can write as individual terms a x to the n? Okay. This one does not. Well, I mean, we could write it, or it is 2 functions multiplied together, so we can use the product rule. Okay, so for our derivative, I'm going to use some color coding here, green and red. So we are going to take the derivative, excuse me, of the first function, 3x squared plus 2, and we're going to multiply it to the second function. So this is the derivative of the first times the second. And then we are going to add the first function times the derivative of the second. So if we look at that second polynomial, we would have 21x to the 6th minus 16x. Now, if we wanted to solve for anything, we would have to multiply that out. But for today's purpose of just finding the derivative, you can stop here. Marcus, do you have a question?
Kind of. So, with the second, like, at the top part, with the second term that's being multiplied be g index, like, would that be a different function?
Yeah. So this, what I highlighted in green is f of x, and what I highlighted in red is g of x.
Oh, okay.
Does that make sense?
Yeah.
Okay. I will warn you, like on a problem like this, your book might have it multiplied out. So this is something where CalcChat may be a better tool to check your answers. I am fine with you stopping here because the whole purpose of the product rule is to save us from having to multiply it. Okay? There are some that I will expect you to simplify, and I'll show you those. But there are some like this one where I say, hey, it's okay to stop right here. Okay? Let's look at another one. Okay? So tell me this. If this were on your quiz, what would you do? You would have multiplied x squared to those 2 terms, which isn't bad, right? And then you would have found the derivative. Okay? Our option today, is this written as a product of 2 functions? Yes, we have f of x times g of x. So if we wanted our derivative, we would take the derivative of the first function, 3x squared, and multiply it times the second function. function multiplied by the derivative of the second. Okay. Now, this would be a case where I don't think that it is too strenuous to simplify. I think that we can do this, and I think it would make our lives easier in the long run when we get to Unit 3. So I would have you rewrite this as 3x to the 4th plus 2x to the 4th plus 2x. Okay, right? Just multiply together, distribute that 2x through. So by the end of it, you could write 5x to the 4th plus 2x. Now, some of you may argue that the product rule is more work for this derivative than just multiplying and doing the power rule individually. No, you don't think so?
No.
No?
Because you have to like multiply everything and then times that.
Yeah. But what we did is we found the derivative with the product rule and then multiplied and combined like terms. You see what I mean? So it's kind of like just doing the same amount of steps in a different order. So what's nice in a problem like this, you're eventually going to have like a choice, right? I could either multiply x squared through and then find the derivative, or option 2, I could find the derivative with the product rule and then combine like terms. You're going to have some options, which is nice, right? It's nice to have different ways to solve a derivative or solve any problem. Okay? One more example. This is something you would have not been able to do yesterday. Is this the product of two functions? Yes, we have x squared times sine of x. Okay. So when we take the derivative of a product, we're going to take the derivative of the first times the second plus the first function is x squared times the derivative of the second. What's the derivative of sine of x? Good, and it is positive. Okay. So the product rule definitely saved us there because we would have not been able to find this without it. Okay. All right, we're going to do something a little different. We're going to do an example without me guiding you, but I'm going to make you like stand up and talk to other people besides who you're with, okay? So I want you to think about, would you rather have a superpower, meet the love of your life today, never feel tired, or own a time machine? Take your notebook and pencil. If you want a superpower, go to the door. If you want to meet the love of your life today, come by my desk. Never feel tired, ironically, please go to the couch corner. And if you want a time machine, go to that fourth corner. Yeah, we don't want time machines. Okay. Nobody wants to meet the love of their life today. Okay. So, based on the corner that you chose, here is your example to do together. So, corner number 1, you have 2x cosine x minus 2 sine x. Nobody gets this one. That's sad. Couch corner, x cubed cosine x. And time machine, you have 3x squared plus x cosine x.
Squared is close to this.
No, okay, so you have two terms, right?
The first one.
Okay, so you do how two X.
We had to see it.
And then, I negative two sine of X equals So I would write this as like minus X sine X, right?
That makes
They want to
sense.
be second science.
So yes, you have really just X plus cosine X. So then that's not the right, that should just.
Right here. First term right here.
Well, okay, so here's the problem. Here's next right here. Okay. That's
No, I'm telling you.
okay, so you have
Think it was.
like more than you basically have to do that once. So what I did is I said, okay, my first function was f times g, and then I did the product rule with x, and my second function 8. When I did the product rule, and the product rule was 0, like, if you want to learn those two, like, well, what I was telling Brett is you would take a derivative of 3x squared, which is 2x, this is the plus, and then x cosine x, so you're going to add this to the product, right? So x cosine x, you're right, you need cosine x, right? Plus x times the derivative of cosine will be negative. So you're taking this is that derivative, and then this collectively is this. Okay, you guys have 3x squared plus minus x cubed sin x. Yes. That's how I want to write it. Okay. Awesome, back to your seats.
I had to.
Okay, we're doing the same.
She said she wants to bring
So you have
Oh.
cosine x minus x.
Everybody like actually needs to understand things literally.
Whoa, maybe your side of the family.
Yes.
Okay, we don't like them.
My grandpa had like 7 siblings.
Uh-huh. And you're
And
like,
like his part, we like
yeah.
absolutely.
So like the first term, yeah, here's the product rule,
Yeah.
and then that
He
second.
was like excommunicated from the family.
Yeah, that's why I only hear this like I'm not saying that, because this is the.
Probably is like my second cousin, it's just they don't want to call
Oh, okay.
So he has to be one time removed once more.
All right. Now, what if I asked you to take the derivative of this?
I'm gonna see it.
It's divided.
Oh.
So what's so the last one we had a product. What do we call this? A quotient. Here is the quotient rule. What? What did you say? It does, yes. Okay, so this one has a little bit more to sort out. Okay, and it's important to remember the order because there's subtraction in the numerator. Okay, so if you have functions that are being divided, we have the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, now growing up, this is how I remembered it. Low d high minus high d low all over low squared. Kind of has a nice little bounce to it, okay? Low just means denominator. D high, that means the derivative of the numerator, okay? High, numerator. D low, derivative of the denominator. You don't have to use this, but I know sometimes we come across rules or things that we have to remember, and some of us just need a cheesy way of remembering it, okay? Kind of like all students take calculus, right? Sometimes it just works, all right? Don't feel like you need this, but you do need to remember this specific order, otherwise your derivative is going to be incorrect, okay? So, does this look, how does the numerator compare to our product rule?
It's subtraction.
Okay, it's subtraction in between. Okay, otherwise, we're following in the same pattern, right? All right, so let's try that one that I had on the screen. Okay, so we have our numerator I'm going to circle in red, and our denominator I'm going to circle in green, just so you kind of have that visual effect of what's happening. Okay, so we are going to take the derivative of our numerator times our denominator. Subtract our numerator times the derivative of our denominator all over the denominator squared. Okay, so we're just gonna free this up a little bit, all right? What we have is 3x squared minus 6, and we're subtracting the quantity when we put that 2x through of 6x squared plus 10x. Okay. So then if we decide to combine like terms, we have 3x squared minus 6x squared. And we have minus 10x minus 6 all over our denominator squared. There's our derivative. Yes?
So we don't have to expand the denominator.
No, no. It's actually helpful to keep it like that because we'll eventually talk about vertical tangent lines. And that's going to be helpful there. Okay. This will probably be our last example. All right, so dy dx. We have the derivative of our numerator. What is it? 3x squared times our denominator. Subtract our numerator times the derivative of the denominator. All over our denominator squared. Okay? Low d high minus high d low all over low squared. Like that. Okay? So now it's a matter of just making it look pretty. Okay? What do we have? We have 3x squared minus the quantity, oh, that would be to the fourth, Mrs. Holman. 3x to the fourth minus the quantity, 2x to the fourth minus 2x. Which means we have x to the fourth minus 2x over x to the fourth. Okay. I would be perfectly happy with that answer. I would also accept the answer of 1 minus 2 over x cubed. Yeah,
Wouldn't that be plus 2x?
it would be. Thanks. It would be. Good catch. Those are things to be careful of.
Would it be okay if we left our denominator as x squared if you want us to?
Yeah, I'm not going to throw a big fit about that. Okay, now why did I go all the way to this right here? Okay, like I said, this answer right here, perfectly happy with. Okay, why did I go all the way to here? Marcus, do you have a question or do you have an answer to me?
Yeah, for x to the fourth plus 2x over x to the fourth,
Uh-huh.
since they all have x, can you like take one out?
Yeah.
Should
Yeah.
you?
You don't have to, no. But could we have done this? Could I have given this to you yesterday? Yeah, we could have just rewritten it as AXBN plus AXBN, okay? We have different ways to do things, but you have to practice product and quotient rule. Otherwise, you're not going to know it for the next quiz. Do your homework, okay? I'm just going to keep adding more rules.